Okay, this is problem 9 on the Math 128 final exam review. This problem is probability. It gives us a situation, a stocking, assuming you can't see through the stocking. And you're going to randomly select marbles, and it wants to know what the probability of these different scenarios are. So the types of marbles are listed in the table shown below. So there's 3 different colors. And for any given color, red marbles could be glass or they could be plastic. Green marbles the same, blue marbles the same. They could be either glass or plastic. So you have this nice table showing all the things that are actually in the stocking. One of the things I would suggest, just to make your life easier in answering these problems, is that you go ahead and make row and column summaries. So like, what is the total number of glass? And through the magic of video, we can add that up real quick. And there are actually 79 of those. And total plastic is 68. If you do this, it just kind of makes things a little easier going forward. 46 of these red ones, 40 green ones, and finally 61. Now the thing you should look for, if I add this column up and I add this row up, I should get the exact same number. And I've checked that out already, and we get 147. And so this is your grand total. There's 147 objects essentially inside this stocking. Okay, so let's start answering the questions. The first one is a OR type probability. It asks for the probability that a marble chosen at random is glass or green. And the easiest way to solve that out is to take a look at, what are the total number of glass or green marbles that are available. So let's take a look at that. Glass marbles, there's 79. And green marbles, there's 40. See how those two numbers have already come in handy. But we have some overlap. Okay, there's 40 in this whole circle, there's 79 in this whole circle, but there are 21 that are both glass and green. They go in this area here, right? So here, there's 58, 79 minus the 21 that are in the overlap. And then here, there's going to be 19 because 21 and 19 make 40. So in answer to the question, if you simply add up the 79 and the 40, you're going to be counting these 21 twice, and you don't want to count them twice. So we need to do one of two things. One, you can do this Venn diagram thing that I've done, and then simply add these 3 numbers inside. And let's just go ahead and do that. You'll get 58 plus 21 plus 19, and you come up with 98. Or you could take your 79 plus your 40 and then subtract off, because this 21 is in here, this 21 is also part of this number, so we want to take out one of those duplicates. And then we do that by subtracting the 21, and if we do 79 plus 40 and we subtract 21, sure enough we get 98. So either way we get 98. We already calculated that there are 147 total objects, and so the answer is 98 out of 147, which simplifies to 2 out of 3. So the answer to this question is simply that the probability that a marble chosen at random is glass or green is 2 out of 3. And of course you're going to want to preserve the work you did to get that, just in case if this number's wrong, whoever's grading your test can go and kind of see your thought process, what you were trying to do, and maybe some of it was in the right direction and could help you get some points. Okay, let's go on to B. What's the probability of the marble chosen in random is red? And this is a given that the marble is glass. So what we're going to do is we're just going to assume that we got a glass marble. There's 79 glass marbles, 26 of which are red. So 26 out of 79 is our probability. And that turns out not to be reducible. And so that's our answer, 26 out of 79. Okay, that's the probability. Because remember, you're assuming that whatever marble you pick is going to be red. So if it's going to be red, then you can ignore all these. And it's just how many, what's the probability of getting a red marble? And it's 26 out of your total 79. Okay, what's the probability of choosing a marble at random that is not a red glass marble? Well, choosing a red glass marble would get you a probability of 26 out of the total, 26 out of 147. But we want the complement of that, or what is the probability of not? Well, we simply subtract the 26 from the 147 and we get 121. So this is, we do get a red glass marble. And this is something other. We get something other than a red glass marble. Could be red. It might be a red plastic marble. Could be glass, but it could be green or blue. So this is the probability that could be anything but a red or glass marble. So we simply write that down. 121 out of 147. And again, that's not reducible. You can try that in your calculator. Remember, the way you do that, you just type 121 ABC 147, hit equals, and if it can be reduced, it'll reduce it for you. And in this case it didn't, so we're just going to leave it the way it is. Okay, now we're going to choose two marbles in succession. What is the probability that the first one is glass and that the second one is plastic? Okay, well, probability of choosing a glass marble is 79 out of 147. See how nice it is to have these totals. And the probability of choosing a plastic marble is 68 out of 147. And so what we're going to do is we're going to multiply these probabilities now. Okay? And that's because we're doing one probability, one event, and then we have an independent event. We're going to take the probability of that. So we have to multiply these two. When we multiply these two, what we actually end up getting is a fraction, which I'm going to express as a decimal, 0.2486. This is pretty close to 1 in 4. So let's just think about this. I'm going to go ahead and write down the answer. My calculator wouldn't give me a nice fraction, so I'm just going to write down 0. And let's think about this. Your 79 and your 68 are both fairly close to half of the total. One's a little higher, one's a little lower. So it kind of makes sense that the probability of doing two probabilities in a row that are 50% would get you something like 0.24. This is kind of like flipping a coin and getting two tails in a row. And what is the probability of getting two tails in a row? Well, you got a 50-50 for the first tail and a 50-50 for the second tail. And so the probability of rolling two in a row or flipping two in a row is the product of those two, which is going to be 1 in 4, which is close to 0.25, and we're really close to 0.25 here. So that's our probability, and that's all it is. Okay, now this last one you might say, well, wait a minute, that's the same question as A's. This says, what is the probability that a marble is glass or green? This is, what are the odds in favor of choosing a marble that is glass or green? Well, odds are simply expressed differently than our probabilities. Probabilities are favorable events compared to the total possible ways. Well, the way to think of this, if there's 2 out of 3 ways, we already calculated 2 out of 3 ways is the probability, then the probability of not getting one is 1 out of 3. So the odds are essentially 2 to 1. Okay, and so we're just going to write 2 to 1. And that's all there is to problem 9. It's a series. You've got 5 different probability questions that are all about the same database. And if you know how to calculate these different probabilities, and really if you just think about them a little bit, I think you can work them out, even if you're not that well versed. But I would suggest that you go back through the material on calculating probabilities and make sure you can distinguish between some of these OR type and then some of these where you do in succession, it's more of an AND type independent events. And there you go, that's problem 9.